Fractions. So fractions come in two basic forms. We could have decimal fractions, which you're used to. 0.25 say. We may have 0.5, it could be 0.6, and anything you like, 0.125. Each of these decimal fractions, these are decimals, will have, may have a direct equivalent vulgar fraction. Vulgar fractions you're used to, 0.25 is a quarter. 0.5 is a half. 0.6 is 3/5, and 0.125 is 1/8. Okay, let's take it a little bit further. We could have a mixture of whole numbers with a fraction at the end of it. So, for example, we could have 3.25. So this is not a whole part, but these are three whole parts. So 3.25. We're not too bothered about that. At this moment in time, this section of your course is concerned with vulgar fractions. Vulgar fractions. There we go. Would help if I could write. So in a vulgar fraction, if we take a quarter, it has two parts. The top part is called the numerator, and the bottom part is called the denominator. We could also have mixtures of these, just like we had mixtures there. And I could have, for example, 2 and 15/16. So this is now a mixed number. Okay. So let's get rid of this one. So picking up at that point, this is a proper fraction. So is this. So is this. So those are proper fractions where the numerator is smaller than the denominator. We can have improper fractions. Those would be things like 4/3, 21/7, 19/3, or whatever the number is. Let me just pick up on this bit. If you get a number like this, then here the 7 will go into 21, and it happens to be convenient. So 7 goes into 21 3 times. So this makes this the number 3. 21 divided by 7 is 3. How many times does 7 go into 21? It goes in 3 times. I'm going to need to remember that. So let's talk a little bit more about whole numbers and mixed numbers. So if I said 2 plus a quarter, and I said just make this as one single vulgar fraction, then we need to know what to do with this. And you've got to consider we're dealing with quarters. These are our denominations, the denominator. So how many quarters are there in 2? So let's go back to schoolboy stuff. There we go. So this is your school days. There's a pizza. I've cut it into quarters. 1 has 4 quarters. 1 pizza has 4 quarters, so 1 whole unit has 4 quarters. 2 will have 8. So this is the same as 8 quarters. plus 1/4. So hopefully that makes sense. So we can deal with a whole number by doing that. Okay. You could, of course, if you'd like, finish that off and you would end up with 9/4. Right, so let's have a look at the basic processes that you need to be able to do as part of your course. Now, I'll keep this very simple. First part that I want to look at is addition. Oops. So, addition of vulgar fractions. Let's do a couple of examples. 1/4 plus 3/8 equals. Let me try and explain the strategy that we need to use. We're going to take these two fractions and we're going to repeat them over here. So that one goes there, that one goes there, but they need to have the same denominator. We want them in the same denominations. So 4 will go into 8, so I'm going to make 8 the common denominator. I can't go down to 4 because this number is already bigger than it. So this number will stay the same, 3/8. And to make 4 into an 8, I multiplied it by 2. So 2 times 4 makes 8. So I'll take the top number, 2 times 1 is 2. And now these are all eighths, and I can add them. So 2 plus 3 is 5/8. Okay, so let's do another one. Let's say 2/5 plus 3/15. 2/5 plus 3/15. That's going to be same as one fraction plus another fraction. We want the same denominator on the bottom, so that means we want the same number that each of these will go into, and 15 is very convenient. So we're going to have 15 and 15. This fraction hasn't changed, so there's 3/15. But this one, I did 3 times 5 to make 15, so I do 3 times the top, the numerator. 3 times 2 is 6. And hopefully, if we add 6 and 3, that gives us 9/15. So I think that was my second example, example 2. Let's do example 3. So in example 3, I have 7/8 plus 3/4 equals fraction plus fraction. We need the common number on the bottom, common denominator. 8 is convenient because 4 and 8 go into it. 7/8 stays the same, that number hasn't changed. Plus, what did I do to this to make 8? I times it by 2. 4 times 2 is 8, 3 times 2 is 6. So 7 and 6 makes 13/8. So that is correct. It just depends whether or not you've been asked to write your fraction or your answer as a mixed number. So this could be 8 goes into 13, it goes in once. And how many 8s does it leave over? It will leave 5. So that would be if you're asked for a mixed number. This is just leaving it as a fraction. It happens to be top heavy or improper, but both of these are correct. I would expect in your exam, this is the style of question that you will probably get. Right, next step. So the next one is subtraction. So subtracting fractions. The method is extremely similar. Let's take 5/8 minus 2/5 equals, we're going to have a number, a fraction, minus a fraction. And we want the same number on the bottom. I made this one a little different to the previous examples, and we need to get a number on the bottom that both 5 goes into and 8 goes into. One of the easiest things you can do there is multiply them together. 5 times 8 is 40. So both of those will go into 40. So on this side, how many times does 8 go into 40? Well, it goes 5 times. So that's the multiplication factor. 5/8 are 40. 5 times 5 is 25. Moving on to this fraction. How do I get 5 to 40? Well, we will multiply it by 8. 5/8 are 40. Okay, 5/8 are 40. 2 8s are 16. So now we've got the same denominator. We do 25 minus 16. So 25 minus 16 is 9 over 40. I cannot make this any simpler. There isn't one number that will divide into 9 and into 40, so that is the answer that we want. So swiftly, I'm going to move on and look at multiplication. Excuse me. So multiplication. Let's take 5/8 times 3/7. So here, this is much simpler than the addition and the subtraction. If we literally take the top line, 5 times 3 is 15. 8 times 7 is 56. And that's it. We could make this simpler if there was one number that would divide into both the top and the bottom, but there isn't. So that is the answer. Let me show you a different one for multiplication. Let's take 2/3 times 3/12. If we multiply this through, 2 times 3 is 6. 3 times 12 is 36. At this point, there is a number that will divide into both of those, and it is 6. So we would take the top and say 6 into 6 goes once. 6 into 36 goes 6 times. And we still have a top and a bottom, so the answer is 1 over 6. Right, finally, let's have a look at division. So division of fractions is most unusual. You need to remember how to do your multiplication to be able to do division. Excuse me. Let's take 3/5 divided by 2/7. There's a phrase here that you're going to need: invert and multiply. So that's what we're going to do to solve this. Take your first fraction and rewrite it. 3/5. So that has gone to there. And then we're going to turn this one upside down, invert it, and instead of dividing, we're going to multiply. So it's times 7/2. At that point, we can multiply just how we did there. 3 7s, 21. 5 times 2 is 10. If you're asked to leave it as a fraction, then that's fine. Otherwise, 10 into 21 goes twice, and it will leave you 1/10. I would expect this is where you would be expected to, how you would be expected to produce your answer.